Geometry, thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 11.1, Circumference and Arc Length. So we are starting chapter 11, not very heavy in theorems, just understanding all the ways that we can use circles and polygons and finding the area of them. So today we're specifically going to be looking for using the formula for a circumference, using arc lengths to find measures, and then solve real life problems to measure angles and radians. First thing we want to understand is what the parts of a circle are that are going to be important for us today. So we have circumference of a circle, which is around a circle. It's the word for perimeter, but since perimeter deals with shapes that have edges, circles don't have edges, we have to name it circumference. You can find circumference by taking pi and multiplying it by diameter, or 2 times pi times radius. Just keep in mind that diameter is that line that goes all the way through the circle, through the center, whereas radius is just exactly half of that, okay? So, number 1 and 2, find the circumference of a circle with a diameter of 5 inches. All you would have to do is take your circumference formula, pi times diameter, so that's 3.14 times 5, and we get 15.7. The next one, find the diameter of a circle with a circumference of 17 feet. So we know circumference is equal to 17. We know pi is equal to 3.14, but we don't know diameter. So to solve this, we're going to take 17 and divide it by 3.14. We're going to get about 5.41 feet. Okay. Next up, we're going to talk about arc lengths. So arc lengths can be found by given a ratio. So this, in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So for example, if we wanted to find the length of AB, then we would want to make sure that we would have AB divided by 360, or if we wanted to find the measure of AB, we can do the measurement of AB divided by 360 times 2 times pi times radius, okay? So those are just some different ways that we can find our arc lengths. We're going to go ahead now and look at an example here. And we're just going to try one for now. So if you look at example A, we have the arc length of AB. So if we don't know what the arc length of AB is, then what we can do is we can apply that same knowledge from the previous slide, okay? So the measurement of arc AB can be found if we take 60 degrees, divide it by 360, and then multiply that by 2 times pi times 8, because that is my circumference, okay? 60 divided by 360 is going to give me a ratio of 0.16 repeating, and then 2, so I'm going to take that number and multiply times 2 times pi times 8. So times 2 times pi times 8. And I'm going to get a long decimal, so I'm just going to shorten it to the nearest hundredth, 8.37. And we'll count that in centimeters. Okay. I'm going to skip the letter B one because, I'm going to skip letter C because that's the same thing we just did here, and instead talk about letter B. Letter B, to find the measurement of XY. What I can do here is set up a proportion. So I can find the arc length of XY and divide it by, or find circumference, maybe labeling that C, is equal to the measurement of XY now. So this is degrees. This is the actual measurement over the degree measurement, which would be 360. Okay, so the measurement of arc XY, or the measurement of XY is 4.19 over circumference equals 40 degrees over 360. one thing I can do is I can simplify 40 and 360 just 1/9, so I'm going to do that first because that's going to make my numbers be a little bit smaller here. If you didn't see that, that's fine, but essentially now all I have to do is cross multiply this 4.19 times 9, and I'm going to get 37.71, okay, as my circumference. And then we'll go ahead and do letter C here. The arc length of RS is what we're looking at, so I can find that by taking the 44 measurement of the arc length, dividing it by circumference, 2 pi r, is equal to the measurement of RS, which in this case I do not know the degrees yet, so let's just label that x, and then divided by 360. So the first thing I'm going to do is 44 times 360. I'm going to get 15,840, and then I'm going to divide that by 2 times pi times my radius, which is 15.28. So 2 times pi times 15.28 gives me 95.90. We'll go and round that to 96. So I'm going to take 15,840, divided that by 95.96. I'm going to come up with about 165 degrees. Okay. The next thing we're going to look at is this example. Okay. It says the curves at the ends of the track are shown in 180 degrees arc of circles. The radius of the arc for a runner on the red path shown is 36.8 meters. About how far does the runner travel to go once around the track, round the answer to the nearest tenth of a meter? So what we want to look for here is, maybe think about this as like 2 semicircles. Or even right here. Measured that way off. There we go. Okay. And if I have 2 semicircles, I'm thinking about they have the same radius, so that can give me just 1 full circle. Okay, so my diameter, I have 2 straightaways, so 2 times 84.39 plus the perimeter, or the measurement of my circumference, so that'd be 2 times pi times 36.8. Okay, because I want that red path of 36.8. So that would give me about 2 times 84.39. And some of you people who run track, you already probably know the answer to this. Plus 2 times pi times 36.8, getting 231.104. So I'm going to add those together, 168.78, and I get 399.884. So we can say the distance is about 400 meters. Okay, or 399.9. All right, next big thing, converting between degrees and radians. So in order to get degrees to radians, we're going to multiply the degree measure by 2 pi radians divided by 360, or pi radians divided by 180. And in order to get radians to degrees, we're going to multiply radian measure by 360 divided by 2 pi radians, or 180 divided by radians. So really what we want to be able to do here is, for radians, we just take pi divided by 180 and multiply it by the degree. Okay, and you're going to leave answer in pi form, which just means have pi in your answer. Okay, for degrees, all you have to do is take 180 divided by pi times the radian. Okay, so this would be just the main thing we want to get from here. Okay, so we're going to try this one. Next on your paper, we have convert 45 degrees to radians. So if I want to go from degrees to radians, pi divided by 180 divided by times my degree. So pi divided by 180 times my degree of 45. So that'll be 45 pi over 180, and then I just simplify 45 and 180. 180 can be divided by 45, it's 4, so this just simplifies to pi over 4 radians. And then this one, I have radians, I want to convert to degrees. Again, if I want degrees, I just take 180 over pi and multiply that by 3 pi over 2, because that's my radian, okay? The nice thing here is that I can cross cancel the pi's. So I have 180 times 3, which is 540 over 2. So I'm just going to divide by 2, and I'm going to get 270 degrees. Okay, see if you can try this one on your own. Pause here, convert from degrees and radians. When you're done, click play so we can check it. All right, if we want to convert 15 degrees to radians, we take pi over 180 and then times that by the degrees. So I'm going to get 15 pi over 180, and then I'm just going to simplify, seeing if 180 divided by 15 works, and it does, so that'll be pi over 12 radians. And then here I have 4 pi over 3, which can be found just the vice versa way. 180 degrees over pi. Pi's can cross cancel, so I'm going to do 4 times 180 is 720, and then divide by 3, I get 240. Okay, that'll conclude our lesson today on 11.1 circumference and arc length, especially with converting radians and degrees. Hope this video helped you, and we will tune in next time when we look at a little bit more of area of circles. Have a great day.